Hello and welcome to the Bowden channel. Today we'll be talking about printing TPU plastics on Bowden setup. Bowden setup because that's what I have on all my printers so far. And why TPU? Because I wanted to print some things that are elastic. So why would anyone want to print something elastic? My personal goal is to print concrete molds with it. And I've already printed a plug for a glass bottle that I will show you. And there are many applications. So whatever you can imagine that is made out of rubber, we can try to do something similar using TPU filament on a 3D printer. So TPU is a thermopolyurethane, and it is, as you've seen, elastic. And the main difference between printing the other rigid filaments is that rigid filaments behaves like a wire. Right, so for example, you can easily push it into the Bowden tube and it's not bending that easily, while the TPU filaments, so thermopolyurethane, as you can see, behaves rather like a rubber band. So as you can imagine, if you want to push it through the Bowden, you can get into a lot of fancy issues, and we'll get into that in a minute. What is Bowden extruder setup? Basically, you have your extruded separated from your hot end. You have extruder motor mounted on a frame of the printer somewhere, and then you have your hot end somewhere else, and there is a tube connecting the two, which is something like that. This is one of my Bowden tubes, and the filament, let's take the rigid one. The filament goes into it, is pushed by the motor, goes out at the other end and gets into the hot end, which is the theory. Why it might be problematic, because if you have any gap in this whole path for the filament, if there's any wiggle room, when you will be pushing this very elastic TPU filament, it can bend, it can clog, it can end up something like this. You see what happened here? So the extruder motor was pushing the filament, and there was some space, empty space, and the filament got turned, crunched, clumped, and you have a blockage on your path. So what we can do to avoid the thing, basically we need to make sure that there is no gap on the whole filament path. So make sure that your Bowden tube gets as deep as possible into your extruder, and on the other end as deep as possible into your hot end. Advantages of the Bowden tube are very simple. You have less mass moving when you print. So basically you can move faster, you can have higher accelerations, plus you have easier access to the elements of your printer, to the hot end, for example. On the other hand, the direct drive setup, it's better because you have a shorter path for the filament. And so when you print with something like TPU, it would be way easier to not to have to fight with the elastic filament in a tube that is 50 centimeters long, for example. So let's get to the challenges that we might have with the Bowden setup and TPU filaments. First thing, as mentioned, is any wiggle room in the path for the filament can cause trouble. Second thing is that pressure in the extruder itself might deform the filament. It can react to some level because it's flexible, but still too much pressure in the extruder will deform the filament that will not fit into the tube. One more thing is that there is some friction inside the Bowden tube, and when you bend the tube, the friction gets higher, right? Because you are effectively making it tougher for the filament to make a turn inside the tube. So in my case, using the so-called Capricorn tube, so the tube that is 1.9 millimeter inner diameter, it was simply not possible to push the filament through even by hand. So I switched to the standard 2 millimeters tube, and Not sure if it's going to be visible, but we can try. Here you can see the regular tube. That's the Capricorn, so that's 1.9, and I'm putting in some of the filament. As you can see, I'm struggling already to push it in. There is some friction, and if I bend it even a bit more, that I can't, basically I feel the resistance to take it out. So I switched to the regular 2mm Bowden tube that is 2mm inner diameter, and it's way easier. It can easily move. Even if I bend the thing a bit more, it is still easy to move. So make sure that you have enough space in the Bowden tube for the filament to effectively move. So when your extruder is pushing on one end the filament through the Bowden tube to the hot end, the filament will get compressed because it's elastic in each direction. So it works a bit like a spring, but it will compress only to some level, right? So I don't believe in what you can read on the internet in many articles, that you need to increase the flow rate for your TPU elastic filaments. In my opinion, you need to make sure that everything is working properly, because if you need to increase the flow rate, it means that something is skipping. You are losing the movement somewhere, right? Other thing you need to do with the TPU filament, you need to limit the speed, because the whole thing gets dynamic because of the elasticity of it. So whenever you try to do things fast, you will get more resistance of these because of this elasticity, right? So basically you try to print with a slow speed like 10 or 20 millimeters per second, and make sure that your flow rate, so the extrusion multiplier, is set to 1 at the very beginning, because I used the standard Prusa template for elastic filaments, and it was set to 1.15, which caused trouble in my case, because when the thing was printed, the pressure was building up on the build plate itself, and with each layer it was getting bigger because the elastic filament was expanding a bit. So with each layer the pressure was increasing, and at some fourth or fifth layer the thing started skipping, and I only later on noticed that I'm over extruding, and this is causing me a lot of trouble. And last final thing is, you need to experiment with each TPU filament that you are printing with. In my case, I had 2 to try, and they were quite different. But in both cases, I finally decided to stop using the retraction for the time being, before I can optimize other parameters. The next challenge is the moisture. Similarly to PETG, TPU filaments are easily absorbing moisture, and when you print, you end up with bubbles of water vapor that explodes basically in your hot end, and you end up with inconsistent print, bad looking print, and that's something that you don't want. A lot of stringing, you don't want to go there. So what you need to do, you need to either simply dry up your filament in an oven, or store it in a dry box with silica gel or some other water absorbent that can help you keep your filament dry. So here you can see these 2 prints. The thing on the right was printed when the filament was still dry, and here the very same filament printed when there was moisture in the air. So they even look like they are different color. And this surface is not nice, because I tried how strong the thing is, so it got deformed a bit. Other final thing about the soft thingy, the TPU filament, is that it can easily tangle around your printer. You are used to the rigid filaments like PLA or PETG or ABS, that simply it will be some kind of an arc between your spool and your extruder. And in case of something as soft as TPU, it can get stuck in places. So make sure that you control it, you use filament guides, that your whole surrounding of the printer is nice and clean. Otherwise, I did that a number of times. You can get tangled, your filament gets tangled with something. Okay, so first practical project was the bottle stopper. I have this IKEA bottle that I keep in my fridge, and after a few months of daily use, the cork was not looking neither nice nor hygienic, so I decided to do a replacement. I designed a multi-part stopper with a rigid core and with PETG in this case, plus the elastic sock and logo that was printed out of the TPU. And here we have a water test. So let's see if it works. Let's pour some water into the bottle and plug it, and yeah, it works. And disclaimer, always use food-safe filaments for such applications. And I think the use of two filaments with different characteristics might be really useful and gives a lot of options for future applications. Okay, time to sum it up. First and foremost, the rule of 3D printing: change one thing at a time. Second thing, print slowly, like 10-20 millimeters per second. You can always go faster once things are stable. Next, check the friction inside your Bowden tube. If it's too hard to move filament, switch to 2 millimeters inner diameter Bowden tube. Then check for any gaps in the filament path, either the connection between the Bowden tube and extruder, or on the other end the connection between Bowden tube and the hot end. Even inside your hot end there might be some gaps and wiggle rooms, all inside your extruder, but that will depend heavily on your setup. Next thing, dry your filament and make sure it is stored in a dry box and you use it even directly from the dry box. Consider printing without retraction, especially when you start to play with the TPU filaments. Once you master it, then you can start experimenting with the retraction. And then, personal advice from my side, set your flow rate to 100% and try to get to the consistent prints without increasing the flow rate. Okay, thanks. I hope it will be useful for your adventures with TPU printing. If you liked it, if you found it useful, give me subs, give me thumbs up, and happy printing. Thanks for watching. See you soon.